So I'm just writing here, free body diagram. Now, I've talked about in previous videos Newton's first, second, and third law, which I'll post to the playlist because I don't feel like making a whole nother video on it. But those are important to know, and I'll put those in the playlist. You'll want to know Newton's first, second, and third law. And now what we're really getting into is how to apply those laws to certain problems, so their applications. Now, we can't just jump into, a pulley problem or some kind of mildly complicated dynamics problem without really giving you the foundation for it. So what I'm trying to do here is spend the next however many videos basically giving you the foundation needed to solve these problems, because what I found is a lot of students don't have that foundation. And if you don't have that foundation, it's going to be really, really difficult. So the first thing I want to talk about, and this will really lead us into the next probably like 5 videos, is a free body diagram. Now, all a free body diagram is it's a diagram that shows us all the forces acting on some particle or some person or anything, really, any system. So let's do the most basic example possible, which is somebody just standing. So the way we do this is we represent whatever the system is, in this case the person, with just a dot. I've seen people draw boxes. It doesn't really matter, but I'm drawing a dot. And the dot just represents this guy. That's all the dot represents. Now, what I want to do is I want to draw arrows representing all the forces acting on them. Forces are vectors. So we would say, for example, hey, gravity is pulling that man down. So we would say, this is the force of gravity. And likewise, there's something called a normal force. Pushing from the floor up on the man. Now, you might not know what a normal force is. That's okay. But first, I just want to explain, hey, a free body diagram. It's showing us all the forces. If we had a car, let me do a different color. But let's just say we had it's an awful road. That's fine. Let's say we had a car. It's an awful car, but it's a car nonetheless. And it's driving. Let's say it has some velocity. And let's say there's friction on this road. Well, the same forces still apply to this truck, this dot here. I'll do it in a different color. The black dot, we're going to say, is just this truck. Maybe the wording of the problem is specific about the truck. So that's what we let that be. And we would say, hey, there's still this force due to gravity. There's still a normal force. Now there's a friction force. And again, just like normal force, maybe just like the force of gravity, you don't necessarily know a whole lot about that yet. I'm sure you've heard friction in everyday world, and you've heard about gravity, I'm sure. But we'll talk more about that in detail. You'll find out friction will, in this case, oppose motion because it's kinetic friction. So maybe we say this is the force due to friction. And we'll get in how you should label this. Just another example. I'm going to do one last example just to show you. Let's say you have a box. And let's say you have this man pushing it. Let's say you have a rope. And this other man pulling it. And let's say there's friction. So this one's got a whole bunch of forces going in on it. So you would still have, again, we'll let the black part be the box. And we're going to label, and we'll get into how to label this. in different ways, different methods. Usually I look at non-contact forces, so things not touching the block necessarily that's having an effect, which is why I always start with gravity. It's kind of hard to get away from. And then I look at everything touching it. So I see, hey, this guy's touching it. He's applying, I'll just say force 1. Hey, this thing's connected to this rope. That's a tension force. There's a normal force. There's the force of friction. You know, all these different things. And I kind of drew this a little funky, but it's just as an example. They're both forces are in the same direction. So this is going to be really important to solve any Newton's second law. It's going to be one of the first things you do is draw a free body diagram. Now, the real problem is there's a whole bunch of different forces. We've talked about some of them. There's gravity, there's friction, there's normal force, tension. There's others, ones you could see from, for example, springs. We could work into Hooke's law. You'll learn about other forces in other physics classes. So what I'm going to do in the next series of videos is talk about all the different forces. So for example, we'll start with good old gravity. I'm sure most of you are okay with this, but I think it's a pretty good place to start. And I'm going to spend, like I said, the next series of videos just talking about the different forces we have in play, because you need to be able to identify them and then be able to draw a good free body diagram from it. So that's kind of our task at hand for now.